Hey folks, welcome to the Numeracy 2023 Term 2 paper. In this particular video, I'm going to go through what you need to do for your questions to get them right. The best way to watch this video is to pause the video at the start of each question, try the question out by yourself, and then see how I go about answering the questions. So, without further ado, let's get started. Alright folks, so for this particular question one here, what we've got is May works at a cafe, gives her $10 for travel, works for 8 hours a day, $22.70. Show how you'd calculate May's pay for one day. So that means we've actually got, she's working 8 hours, so we're going to do 8 times $22.70 plus $10 for the travel itself. So that's pretty much how you do this question. You are allowed to use calculators in these particular exams. I'm using this one here, and I think you might have seen me use the FX8200 as well. So either one, as long as it works, you're pretty much good to go. But in saying that, also just double check your calculator is actually allowed for this paper. Most of the Casio calculators are allowed, so you should be okay with it. Anyway, going back to this question, we've got $191.60. Now, I know when I actually was working with this question with my class, one of my students actually said, well, it should be actually $201.60. And I was like, why is that? What if it's $10 for travel each way? So sometimes you might, you might actually see that as $10 per single trip of the travel. So if that's the case, you might actually do 8 times $22.70 plus 2 times $10, which means you're going to end up with $201.60. Now, having a look at the answer schedule here, they do accept both answers here. They do accept 191 as well as $201.60 as well. Cool, let's go to the next question. So the next question we have, Kyle is paid $27.30 to deliver all his papers, takes him 90 minutes. How much is Kyle paid per hour? Now, I guess for this one, we've got to actually change 90 minutes into hours. So if we think about it, we've got 90 minutes and we want to convert this to hours. So to convert this to hours, what we're going to do is we're going to do 90 divided by 60. Because we've got 60 minutes per hour. So if we do 90 divided by 60, we end up getting 1.5 hours. So if Kyle is getting paid $27.30 for 1.5 hours, then what we need to do is we need to do $27.30 and we're going to divide it by 1.5. So $27.30 divided by 1.5, and what I've got is 18.2, so that's $18.20 per hour. All right, going to question C here. So question C, what we've got is Kate mows the lawn, container holds 5 liters of petrol, it's quarter full. Petrol costs $2.76 per litre. How much will it cost Kate to fill the rest of the container? So the first step we need to do is we need to figure out how much of this petrol can is actually empty. Now it says it's quarter full. So what I can do is I can do a little bit of work here. So I'm going to go full and I'm going to work out what quarter of 5 is. Now this is the same thing as saying quarter times 5. So if I want to do that, I'm going to use the fraction button. 1/4. No, let me just try that again. 1/4, and I'm going to do 1/4 times 5. So this is going to give me as 5/4. And of course, with these calculators, remember that you can actually go between decimal and the fraction using this button here. So as you can see, a quarter of 5 is 1.25. Now, if it's 1.25 liters full, we've got to do 5, take away 1.25. And when we do that, we're actually getting 3.75 liters. So it's actually 3.75 is how much that we can actually fill up this can with. And we've got $2.76 per liter. So what we're going to do is we're going to go 2.76 multiplied by 3.75. And that's going to give us how much it's going to cost. So 3.75 times 2.76, and that gives us $10.35. Awesome. Let's go to the next question. Question D. Now question D is asking us to look at the graph above. In total, how many searches were made for nurse and paramedic? So we're actually looking for two things here. We're actually looking for nurse, which is along this line here. Let me just try that again. We've got the nurse here, and then we're looking for paramedic, which is along here. And we're looking at roughly the total of how many searches were made for nurse. So for the nurse, what I'm going to do is I am going to just draw this little green line roughly here. And for the paramedic, roughly the blue line there. So looking at this, you can kind of say that this is probably around, for the nurse, it's probably around close to 40,000, so but not 40,000. So I probably would go with something like, and again, this is an estimate, remember that. So I could go with 39,000. And as for the blue, I might go with something like, it looks like 27, 28 maybe. And what I'm going to do is I'm going to add up those two numbers. So when I do 39,000 plus 27,000, I am getting 66,000 as my estimate. So I'm going to put down 66,000. Now when I look at the answer schedule here, basically what they've said is as long as the answer is between 60,000 and 70,000, you're pretty much good to go. Yeah, and that's pretty much what you need to do for this question. We go to the next question. Right, so the next question, what we have is Lily's cutting this pizza. We've got equal size, calculate the angle. So the first thing to remember is that we've got all the angles inside around a point adds up to 360 degrees. So for the first small pizza, I'm going to take 360 degrees and I'm going to divide it by 4. And when I do that, I get 90 degrees. Then I'm going to do it for the medium pizza. Medium pizza is getting divided into 6 pieces. So divided by 6 is going to give me 60 degrees. And finally, the large pizza, 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces. So I'm going to do 360 and I'm going to divide it by 8. Oh, what have I done? Okay, now I see what I did. 360 divided by 8. That's going to give me 45 degrees. And for this particular question, you actually need to get at least 2 of these numbers correct for you to get this question correct. All right, next one. Now I do have to apologize, folks. I know that there are some images that needed to be kind of blacked out here because partially because of just photos with copyright issues. So yeah, some of the questions you kind of just have to imagine and just kind of work through it. So let's have a look at this question here. So with this question, what we've got is we've got somebody that's actually helping to build a rectangular deck. All right, so we're going to actually do that first. We've got a rectangular deck. The deck will be 8 meters long. So this is 8 meters and 2 meters wide. This is 2 meters. Now it says 1 meter long strip of wood is called linear meter. Great. And then it says each square meter takes 11.5 meters of wood. Okay, so that means 1 meter squared is going to take 11.5. Now I probably would put this as 11.5 linear meters. And then the question says, TUI says about 190 linear meters is required to build a bed. Is she correct? Use measurements to explain your answer. Okay, so the first thing we're going to do is we're going to actually work out the area of the deck. So to work out the area of the deck, it's a rectangular shape. So we're going to do base times height. If we do that, we're going to do 8 times 2, which gives us 16 meters squared. Now it basically says that for 1 meter squared, it requires 11.5. So then for 16 meters squared, we're going to do 16 meters squared times 11.5. But really what we're doing is just 16 times 11.5. So we're going to do 16 times 11.5. And when we do this, we get 184. And this is 184 linear meter. Now, TUI actually says that 190 is needed to build a deck. Now, with this particular answer, now this is where things get a little bit tricky with numeracy correct papers. Now, it says, is she right? Use measurements to explain your answer. Now, if we want to go, actually, she is not correct because she actually said it's 190 and we're actually only using up 184. You could actually say, no, she is not correct because it doesn't require 190. It actually only requires 184. But at the same time, you could also say she is correct because 184 is actually quite, while it's not exactly 190, but it's actually kind of close to 190. So you could actually kind of say that as well, and just also might say something along the lines of like, you might use 190 because, you know, she might actually waste some wood or something like that, right? Like, so just remember that with these ones, the key part is not just using the measurements to explain your answer, but also the key part is explain your answer. So like I said, if you said yes, is she right? You could say yes, because 184 is close to 190. You might actually say no, because 184 is 6 less than 190. So as you can see, there's a, you know, either answer is correct, but it mainly the important part is you explaining your answer. So that's something that you just need to keep in mind for this particular exam paper. All right, so let's go to the next question. So the next question, what we've got is Ingrid picks kiwi fruit. She's paid $33 for every bin she fills. Right, she averages 1/3 bins per hour. How much money should she expect over 10 hours? So the first thing what we want to do is we actually want to try and work out how many bins she's going to fill out in 10 hours. And to do that, what we're going to do is we're going to take 1/3, because she fills up 1/3 bins per hour, multiply it by 10. That's going to give us the number of bins she's going to fill up. But she's also getting paid $33 for every bin. So once we get the number, I'm actually going to do this in 2 steps, right? So let's actually do this part first. 1/1/3. So we've got 1. Is this going to work? No, it's not going to work. All right, folks. So what we're going to do is we are going to do 1/1/3 times 10. So I just want to make sure I did this right, because I know the last time I was messing around with this, I got it as a mistake. So we're going to put this mixed fraction, 1/1/3, and we're going to multiply it by 10. And when we do this, we are getting 40/3. So that's giving us an indication that's 40/3 bins. We can convert this to a decimal. It's going to be a recurring decimal. So that's about 13.33 bins. Next, what we're going to do is we're going to multiply this by 33, because that's going to give us 40/3 times 33 is going to give us how much money she's actually expected to make. And that's going to be $440. And once again, we had a really interesting conversation with this particular question, right? Like, we had this idea that she gets paid $33 for every bin. And because it's every bin, do you then go along the lines of like, well, she only gets paid for the full bin? But of course, we don't really have that information here. So we're going to assume that she's going to get paid for a half a bin or a quarter bin, or in this case, 40/3 bins. Anyway, folks, let's go to the next question. All right, so with this particular question here, what we've got is percentage of secondary schools with part-time jobs. There's a bit of a decline for the year 13s. Interested to know why, but is the following statement true? The percentage of year 13 students with part-time jobs is greater than the percentage of year 11 students with part-time jobs. Explain your answer using numbers from the graph. Now, folks, for this particular question, there's actually quite a few things that you can actually say here. When you look at the percentage of year 13 students is greater, apart from the year, I don't know, it looks like 2003 maybe. Apart from 2003, you can almost say that the percentage of year 13 students with part-time jobs is always bigger than the percentage of year 11s. Because if you look at it, year 13 is higher, year 13 is higher, all the way down to up till 2003, and then after that there's another spike where the year 13s are actually, the percentage of year 13s have part-time jobs, which is more than what the year 11s actually have. So in terms of the answer, you could actually talk about 2023 itself, which is right at the end there. You can see that the year 13s, there's a higher percentage. Really important that you talk about the percentage rather than the number of students, because on the y-axis for this particular graph, what you have is the percentage of students. So it's not like 80 students are doing more than, like for example, you wouldn't actually say this here as 80 students. That's actually 80%. So it's just something to keep in mind of. But apart from that, yeah, you've got a lot of different points you can talk about. You can talk about 1970s, 80s, 90s. Apart from that 2003 year where the percentage dropped, but everything else, I think you can actually say it's actually higher. But just use those points, right? Use the points, use the years as well. So here's like a good indication of like what some of the years you could use. So I was using that 2003 because that was like a nice little reference point. But it also looks like it's actually going up in 10 years, because if you look at it, it's saying from 1973 to 2023. So that's going to be 73, that's going to be 83, 93, 2003, 2013, and 2023. So again, that's just having a look at the graph and using those numbers to explain your answers. Folks, that's question 1 done. All right, folks, so let's go to question 2 here. Question 2, we've got a bunch of New Zealand birds. Unfortunately, I don't have their pictures. One card will be chosen without looking. What's the probability that the chosen bird has a name starting with K? So altogether, we've got 14 cards here, because that's what it's saying. We've got 14 names there. Starting with a K, we've got 1, 2, 3, 4, 5, and 6. So basically, the probability is going to be 6 out of 14. Now it actually says you can give it as a percentage, decimal, or fraction. So if you were to give it as a fraction, you would write it as 6 over 14. If you wanted to do it as a percentage, you would actually go 6 over 14. I'll probably put that as a decimal first. So as a decimal, it's going to be 0.4286. Let's go with 86. Is it 8586? 86, yep. And then as a percentage, we just need to multiply it by 100, which means we're going to get 42.86%. Sorry. So there's that 42.86. Okay, so that's question A done. Question B, what we've got here, we've got tiny bird that weighs about the same as 1 biscuit. So we're just going to write that down here. So we've got 1 bird equals 1 biscuit. Packet of 10 biscuits weighs 200 grams. Okay, so 10 biscuits is equal to 200 grams. Then it says select which operation gives the weight of 1 PYY in grams. So that means we're looking for a weight of 1 biscuit. And to do that, we're going to go 200 divided by 10. That's the 4th option there. It's going to give a little tick. And that's pretty much it. We move to the next part. Next question, it says question C. 1998, there were about 100,000 Kiwi left living in New Zealand. In 2023, there are about 68,000. By what percentage have the Kiwi numbers gone down between 98 and 2023? So first off, we've got to actually figure out how much this number has reduced by. And to do that, what we're going to do is we're going to go 100,000 minus 68,000, and that's going to give us 32,000. So it's actually reduced by 32,000. So to find this as a percentage, what we're going to do is 32,000 divided by the original number, which was 100,000, multiplied by 100, because that should give us what percentage the population, the percentage has actually decreased by. So we got 32,000 that's already in the calculator. So we're going to divide it by 100,000, and then we're going to multiply it by 100. And when we do this, we get 32%. Cool. Next question here, 2D. We've got a moa as an extinct bird. Large moa weighs 230 kilograms. Large kiwi weighs 3,300 grams. About how many times heavier was the moa than a kiwi? So the first step is we want to convert either all of your units to kilograms or all of your units to grams. Now, if you're going to work with kilograms, then moa is 230, kiwi which is 3,300 grams. So we know that there's 1,000 grams in 1 kg. So we can go 3,300 divided by 1,000. Now that's going to give us 3.3 kgs. Now if you decide to choose to work in grams, kiwi would be 3,300, and 230 kilograms converted to grams is 230 times 1,000, which is going to give us 230,000 grams. So it doesn't matter which unit you go with, because ultimately you're looking at how many times heavier. So let's try 230 divided by 3.3 first. And if I do that, I get roughly 69 to 70 times more heavier. And had I chosen to work with grams, I would then go 230,000 divided by 3,300. And that's still going to give me that same value of 69 to 70 times more heavier than a kiwi. So you could actually write this as 69.7. You could write it as 70, 60, 69, not 60, sorry. Anywhere between 69 and 70. Now what I'm going to do is I could actually just say, the answer schedule actually says 69 to 70 times heavier. And yeah, you could potentially do that as well, but I don't think you'd be pinged for writing it as 69 times heavier, or even 69.7 heavier. All right, so let's have a look at question E here. So question E, what we've got is Bird of the Year competition. I would love to see the stats for 2023, but that's another story. We're gonna come back to that maybe next year. Graph shows the number of votes for winning bird since 2008. About how many votes did the winning bird get in 2017? So to work out 2017, it's halfway between 2016 and 18, and we're looking at somewhere along there. And I guess having a ruler is quite handy, and I'm just going to kind of place that there. So it looks like somewhere between 7,000. It's not 7,500, because that's 7,500. So I would say anywhere between 7,000 to 7,500. I mean, you could actually say, I probably would go 7,250, but the answer schedule does say if you get your number anywhere between 7,000 to 7,500, you should be getting that correct. Next question, 2F. So if you look at this particular graph, someone has claimed that the number of kakapo in 2022 is 4 times the number of kakapo in 1994. Do you agree? So first, we actually need the numbers. So we're going to look at 2022 first, which is here. So this is 2022, and roughly speaking, so these are all going up in tens. So that's going to be 210. Probably I'm thinking like 208, 209. So I'm going to go with 208. Then I'm looking at 1994, which is right here, and I want to know how much that number is. So if this number is 60, I probably would say there's about 52. That's roughly, all right. I mean, I just picked random numbers here, but now it says that it's 4 times the number of kakapo in 1994. Now what I could do is, to do that, I would actually go 208 divided by 52. Now in this particular case, 208 divided by 52 is going to give me 4. Now according to my numbers here, I can actually say that yeah, I can agree with it, because it is about 4 times more than what it was in 1994 compared to 2022. But that's because of the numbers that I picked. Now if for some reason you decide that in 2022 it's not 208 but rather 209, then you might get something like this. You might actually go 209 divided by 52. If you were to do that, then you're going to get more than 4. So again, as I said to you folks earlier with these types of questions, right? Like you've actually got 2 kind of answers you could say. If you get exactly 4, you'll say, yep, I agree, because it's actually 4 times more than what it was in 1994. But if you say, if you did the 209, then you might actually disagree, because it's not exactly 4, it's actually slightly more than 4. But then you could also agree that it's close to 4, therefore it's still 4 times more. So it's a bit of a, how do you call it? It's a bit of one of those weird questions where you can give either answer, but really important that you actually explain your answer. Now, my particular numbers that I picked, I got 208 and 52, and it kind of worked out real nicely. So therefore, I'm going to say, yes, I agree. And I'm going to talk a little bit about, because I can see that 208 was the number of kakapo in 2022. And in 1994, I had 52 kakapo. So that divided as 4 times. So I can actually agree with it. So you've got to actually use the numbers to say whether you agree or disagree. All right, so let's have a look at question 2K. The movement of Cheeky the Kia was tracked for 1 day. Select which answer is closest to the total distance that Cheeky flew. It's like we've got 500 meters. All right, so we've got about 5 different answers here. Now, like without even measuring, right, I'm going to start canceling out a few things. Because what you could do is you could actually take a ruler like this, I kind of like measure this line, like how far this line is. So that looks like it's about 0.7. Yeah, I don't think this ruler it actually is not. This is a digital ruler, so it's not really giving me the units. But then what you would do is you would probably go how many of these lines you could actually fit along here. All right, and like right now I'm just doing like a rough estimation, but let me show you how I can actually eliminate some of the values. The first thing is I know that this is not 700 meters, because if this distance is 500 meters, 700 meters is probably like roughly up to there. So it's not 700 meters. 70,000 centimeters, I need to convert that into meters. So I know that 100 centimeters equals 1 meter. So 70,000 centimeters is equal to 700 meters. I always get confused, but let's just check that anyway. 70,000 centimeters divided by 100. Yeah, it's 700 meters. Now 700 meters, again, that is something that we already have, don't we? Because we actually have that at the top there. So both of those answers are getting eliminated. Now the next one I can look at is 70 kilometers. Now I know that this right here, like roughly this, is 1 kilometer, because twice this distance is like adding another 500 meter, which means this is 1 kilometer. So I definitely don't think the area, like, from here to here is roughly the 2nd kilometer. So I don't think it's going to be 70 kilometers. Now the other thing we can also look at is 70,000 meters. 70,000 meters, so if you look at it, 70,000 meters in kilometer equals to 70 kilometers. So basically what I've done is, without even measuring this using any kind of measurement, what I've done is I've actually eliminated the wrong answers, or the too high or the too low answers. And right now I am eliminating this, because 70,000 meters is the same thing as 70 kilometers. So I'm going to cancel that out, which means the only option that's left over for me that's remotely correct is 7,000 meters. Now you could actually try and do what I did with that red line there. You could potentially go, okay, so that's 2, then 3 would be from there to there, so that's going to be 3 kilometers, and then you can probably kind of keep doing little by little those little 500 blocks, and then you should be able to get close to 7,000 meters as well. 7,000 meters, it's about roughly 7 Ks, and that looks all right there. All right, folks, that's basically question 2. We go to question 3 next. All right, so for question 3, what we've got is we've got a manu tukutuku, traditional Maori kite. We've got the width, which is 3,660. So this is this distance here from 3,660. And we've got to figure out what the estimate of the height is. Now, looking at this, it's tempting not to just measure it and just figure it out that way. There's a couple of ways you could do this, because the first thing is that you've actually been given the amount of measurement, you've been given a scale, right? So you could use that scale to try and work out what the height is. Now, what I'm going to do is, what I would have done is I would have actually used like a real ruler. I would have figured out what that millimeters is and then kind of put it on the side to figure it out. But in the software that I'm using right now, I actually have to use a digital ruler. So I'm going to try and show you how this works. So if I start at 0, oh, look at that. That's like one block. Like say, for example, here to here, that's about 500 millimeters. So then I'm just going to flick this to the side here, and I'm going to try and kind of line it up here. So there is 1, 2, 3, 4 and a bit. 4 and a bit. Is that right? I'm just checking. Hold on. Is that 1 or is it 9? No, it's definitely 1. And then if I was to do it this way, 1, 2, 3, 4, just over 4. So I reckon I could probably go with like 2,100 roughly, I would probably say. That's one way of doing it. So I might say 2,100. The other way of doing it is kind of looking at it this way, right? So here I'd actually go measure it from here to here. So that's going to be 1, 2, 3, 4, 5, 6, 7. Yeah, it's like 7.5. Yeah, 7.5 times 500, roughly that. So 7 of that, 7.5, and then here we had 4. So you could almost kind of say that, it's half of, just over half. So that's another way you could do it as well. So you could kind of use the rulers to kind of measure it out. But I think the easiest way is to use the scale there, where it's, where you take that unit as 500 millimeters and then kind of work it out. So we're looking at just 500 times 4 plus a little bit. So I probably would stick with 2,100. All right, so let's have a look at question B. Now with question B, what we've got is 1 knot is tied in the circle in this photo. We've got 22 sticks running horizontally across. All right, so that's basically like this. And then 7 sticks vertically. Now we can actually see the 7 sticks because we've got 1, 2, 3, 4, 5, 6, 7. And I guess the 22 is kind of like all of those things that's going up. Now, that's the body part of it. We're not worried about the wings here. So if that's the case, then we've got to actually show how we'd work this out. So I'd probably go 22 times 7, which is whatever that is. Let's just have a quick look. 22 times 7, that is going to give me, where is it? 22 times 7, that's going to give me 154 knots there. And that's question B. Finally, looking at question C here. What is it? We've got a flying the kite from Matariki. Here are 2 views of the Matariki flying over PA. Okay, PA over a PA. One view is from the south, one view is from the east. So from the south, we're looking at it this direction. So this is the south direction, and then this is the east direction. And I guess we're trying to figure out where the position of the Mana Tukutuku is from the view above. So if you look at it, it's almost like you have to match the 2 diagrams from both sides, and you almost have to learn how to look at it visually. But if you look at it from the south, from the bottom, it is definitely not B and D, because if you look at it, like if you look at the fence, right, the fence actually goes all the way around like that. So it's inside the inner fence. That's something that we know. So it's inside the inner fence, which means it can only be A, E, or F, and C. Now, when you look at it from the east view, you are looking at it from this direction. And we're looking at it that's closest to the left side. So it's kind of like turning your thing. So this becomes your left side of the view from the east. This becomes the right side of the view. And if you look at it, the furthest point is almost E there, because C is more like in the middle of the mountain, because if you look at it from the south, you're looking at more left and right. So if you look at it, that's the left of the mountain and the right of the mountain. So you're probably looking somewhere along this line, And then when you're looking at from east, you're looking at somewhere along the blue line. And I think the best one to look at is then it becomes E. Right, that's question 3. Let's go to question 4. So question 4, what we've got is an octagon shaped garden frame. Again, I didn't get, what do you call it, a shape. I should have actually put a shape in there. All sides are the same length. The perimeter of the frame measures 6 meters. And what is the length of one side? So all we're doing here is perimeter is 6 meters. So we're going to go 6 meters divided by 8. And that's going to give me 6 divided by 8. That's going to give me 0.75 meters. So that's what each panel on that octagon is actually worth, or each side. Question B here. What we've got is in the garden frame, all internal angles are equal. Each external outside angle measures 45 degrees. How many degrees does each internal angle measure? Now, we know that if the internal angles are all the same, this is going to be X, this is going to be X, and so on. But we also know angles on a straight line adds up to 180. So we could go 180 minus 45, which is going to give us 135 degrees. And that is pretty much how you do question B. Now let's have a look at question C here. Question C, usual price of this frame is $310. This month you get 20% off. What's the price of it? Okay, for this month. So we're going to actually work out what 20% of 310 is. And the way we do this is we write 20% times 310. 20% is the same thing as saying 20 over 100 multiplied by 310. So we got 20 over 100 times 310. That's going to give me $62. So the new price, it will be 310, take away 62, and that gives me $248. Cool. Let's go to the next question here. Question D. We've got Rob the gardener says that he can find the inside area of the octagon by using these calculations. All right, 1.72 and 1.72. And then he's got 2 times 0.5 times 0.5. Okay, so what we're going to need to do is we're going to need to explain how he's getting the area for this particular octagon here. Now, for this particular question, what we are asked to do is we're actually being asked to give the information of what Rob has actually done, right? So whether he's done it right or wrong, that's one story, but then we've got to try and figure it out. Okay, so if you look at it, the 1.72 times 1.72, this first step, what he is doing is he's actually working out the area of this square. So this is what that 1.72 times 1.72 is. So sorry, this is a terrible square, but hopefully you get the idea. So okay, now let's try that better. There we go. So that's going to be my square. That's 1.72 times 1.72, which is 2.96. Now the next thing is he's actually done 2 times 0.5 times 0.5. Now the reason that he has done that is because he is literally taken these 4 triangles. So there's triangle 1, triangle 2, triangle 3, triangle 4, and he's combined them as 2 little squares. So there's the first triangle and second triangle, third triangle and fourth triangle. So hopefully you can see that. That's 1, 2, 3, 4. So 1 and 2 is there, 3 and 4 is there. And this is where he gets that 2 multiplied by 0.5 times 0.5. So what he's doing is, in that second line, he's actually calculating the area of the triangles. But he's got 4 triangles or 2 squares. So that's equal to 0.5 meters squared. Now, if he subtracts the big square with the 2, subtracted with the 4 little triangles or the 2 squares, he is going to end up with the shape that is the octagon shape, which means he will now get an area of 2.46 meters squared. So really important that you kind of verbalize it. So when I say verbalize it, you've actually got to write what's happening there. So I might write somewhere along the lines of like this. Here it's area of big square, and then I would say something like area of 4 corner triangles combined, and then finally equals octagon. But of course my explanation is terrible here, so I would actually expect you folks to actually write a bit of a few sentences explaining what's happening for that particular question. All right, so the next part of this question is we've got topsoil comes in bags of 25 liters. He works out that volume of the frame is 0.8 meter cubed, which is the same as 1,000 liters. All right, so we've got a shape here and the volume is 0.8 meter cubed. So what we are trying to figure out is if 1 meter cubed equals 1,000 liters. First off, try and figure out how much is 0.8. 0.8 meter cubed is going to be what? So the way we're going to do it is we could actually do this as ratios. So 1 is to 1,000, and we want to know what it is to get to 0.8. Now there's a couple of ways of doing this particular ratio, right? So you could actually go, what number am I dividing by 1 to get to 0.8? So you could do something like this. So you could have gone 1 divided by 0.8 is equal to 1.25. So that means I need to divide 1 by 1.25 to get to 0.8. That means I got to do the same thing on the other side. So I got to go 1,000 divided by 1.25 is going to give me 800 liters. So I am going to need 800 liters of topsoil. With that in mind, I know that each bag has 25 liter bags. So I need to actually figure out how many bags of topsoil do I need. So then I've got to go 800 liters divided by 25 liter bags, which is going to give me 32 times 25 liter bags. So that's basically saying I need 32 bags to actually fill up that 800 liters of topsoil. All right, so question F here. So with question F, Rob's planting flowers. Ratio of white flowers to purple is 2 to 3. So we've got white to purple, 2 to 3. Has he planted this correctly? Explain your answer using the number of white and purple flowers. So if I count the number of white flowers, I've actually got 9 there. Then I'm going to count the number of purple flowers, which is 8 and 8 and 8, 16. Now what the question's asking is, has he planted this garden with the right ratio, right? Now if we look at it, we've got 2 to 3 and 9 to 16. Now if I was to actually convert, like let's just have a look at 2 to 3. If I do another 2 to 3, I'm going to multiply everything by 4. And what's going to happen is I'm going to get a ratio of 8 to 12. I know that ratio-wise it doesn't actually make sense. Now there's so many ways in which you can do this question. You could look at how many purple flowers per white flower. So if you were to do that, you would go purple to white ratio is 3 to 2. Or 3 over 2, which is the same thing as saying 1.5. That means if you plant 9 flowers, 9 times 1.5 is going to give you, let's see, where is it? It's actually going to give you 13.5. So this is one way you could say actually his ratio is not correct, because for 2 to 3, if he's, well, for starters, he can't actually plant 9 because it's 1.5. The ratio, it's like 1.5 purple flowers per white flower. So it doesn't make sense for 9. It doesn't actually work because you're going to get like a half a flower. So it doesn't work for that. So that's one way of doing it. The other way you could do it is you could actually look at the ratios themselves, like try and find like a common, lowest common multiple kind of idea. So like look at this one here. So you have 2 to 3, 9 to 16. If I double 9, I'm going to get 18, and 16 times 2 is 32. Likewise, so what I did was I did times 2 and times 2. Here I'm going to do times 9 and times 9. And when I do that, I'm going to get 18 to 27. So according to his original 2 to 3 ratio, if he has 18 white flowers, he should have 27 purple flowers. But the one that is currently planted, he's actually got more than that particular ratio, and therefore he is actually incorrect. So a lot of different reasons you could actually use for this, but ultimately we're just looking for one of those reasons. And folks, that's basically question 4. Question 5, what we've got is SPCA fundraising, cupcakes. 2022, there were 206 Street Week fundraisers. On average, how much money did each fundraiser make? So what we're going to do is we're going to look at 47,307 divided by 206. 47,307 divided by 206, and that's going to give us $229.65. Well, that's pretty straightforward for question A. Question B, we've got 47,000 raised in 2022. They want to increase it by 5%. So what is the total amount that they want to increase? So we've got, for part B, we've got 47,307, and they want to increase it by 5%. Now, a couple of ways of doing this. First, we can work out what 5% of 47,307 is and then add it. Or you could actually multiply by the coefficient, ratio coefficient, which I'll show you both, all right? So the first step is I'm going to work out what 5% of 47,307 is. And to do that, I've got 5 over 100 times 47,307. 47,307 times 5 divided by 100. That's going to give me $2,365.35. Now I want to increase this by this percent. So I'm going to do 47,307 plus 2,365.35. So I'm going to add 2,365 and 30 cents to 47,307, which gives me an answer of $49,672.35. So this is pretty much answer for question B. So I've got 49,672.35. It's interesting because it's like in the answer schedule, they've actually said allow answer between 49,000 and 50,000. So you got a bit of leeway there. All right, so let's go to the next question, 5C. What do we got? Cupcakes that has been sold, 240 that was sold. Is the following statement true? About 1/3 of the sales were chocolate flavored cupcakes. Explain your answer from the graph. So first off, we need to figure out what 1/3. Okay, so we've got 240 that was sold. So if it's 240 that was sold and 79 of it was chocolate, we've got 79 out of 240. And again, this comes back to what we were talking about earlier, right? Like, so if you decide that you can actually accept this claim or you could reject this claim, all right? And the way you do that is if you do 79 over 240, let's say we go 79 over 240, that's going to give you 0.3291. Now you're like, well, what? Okay, let's have a look at what 1/3 is. If you do 1/3, 1/3 is 0.333. So the way you would answer this question is you could say, no, it's not true. If it was 1/3 of 240 cupcakes, chocolate has to be 80. But in this case, it's 79. Therefore, it's incorrect, the statement. On the other hand, you can say, yes, I agree with this statement because 0.329 is very close to 1/3. Therefore, this statement is true. So it's one of those weird questions, again, where you could write either or, but the most important part is you've got to explain why you chose yes or no. So I'm going to leave that there for you. Like I said, that's 79 over 240. Now, the other way you could have done this is because you had 1/3, you could write that as 80 over 240, because 1/3 is the same thing as saying 80 over 240, which is an equivalent fraction. And then from there, you could have also made the claim as well. Yes, it's pretty close, or no, it's not 80, therefore I reject the statement. All right, so let's go to question D. So question D, what we've got is Remy buys these ingredients to bake 24 lemon cupcakes. What is the cost of the ingredients for one cupcake? All right, so all of this is the cost of ingredients for 24 cupcakes. So we're gonna have to add the total cost of these ingredients and then just divide it by 24. So we've got $12.40 plus $5.40 plus $2.59, $3.90 plus $1.69, $6.59 plus 2 that's going to give me $34.57. $34.57 divided by 24 cupcakes. So I should be charging $1.44 for each of these. What's the cost of ingredients? Yeah, so actually no, the cupcake cost of ingredients for one cupcake is going to be $1.44. All right, let's have a look at the next question. All right, so we've got Remy takes 24 cupcakes to school in a rectangular tray. 7 centimeters is the diameter for each cupcake. What are the length and the width of Remy's tray? So we've got 7, 7, 7, 7, 7, 7. I guess, I mean, you can kind of say this is the length and width. It doesn't really matter because it's a rectangle. So we've got 1, 2, 3, 4, 5, 6, 7. So that, no, 7, no, we got 6 sevens, which is 42. Then we've got 7, 7, 7, 7. That's equal to 28 centimeters. So we should have 42 and 28. And I don't think the order matters, people, because it's a rectangle. You know, length and width is the same thing as saying width and length. So it wouldn't matter as long as you have the numbers correct. Finally, the last part of this question. Now, for this question, I have to apologize. I wasn't allowed to use the original image, so I did create the closest image that I could generate it. So there we go. Have a look at this particular cake, and you can kind of have a look at what image most closely matches the side view of the cupcake. Fairly straightforward, this one here, so you can kind of see that it's F. I really wouldn't want to be having a cupcake that looks like C or E. Looks like C has been bitten. B has definitely been bitten as well. You know what I would love to do? I would love to create a bunch of images where the cupcake's side view looks like that, because I'm sure it's going to be like bitten and eaten off from the side. But anyway, for this question, we're looking at letter F as the as the side view of this particular cupcake. All right, folks, that is basically question 5, which is the last part. Well, that is the last question. So folks, if you do have any questions, put it in the comment section below. There is a big numeracy co-requisite playlist that I've been kind of working on slowly. Have a look through that. Also, if you do have any comments, just pop it in the comment section. You know, it's always nice to hear from people, how they're going about it. And also, one last thing, if you are using this, yeah, definitely send me an email as if it's been helpful or not. Just kind of collecting some evidence for a couple of things, so would love some feedback from you. But as for this, good luck for your upcoming test. Alright folks, that is basically it for this video. As always, don't forget to like this video, share this video, and subscribe to keep up with the latest content. Now, there should be a couple of playlists popping up here and here. Great material for revision, and as always, thank you for watching.